I've got a bunch of ACT tests on my computer. I have like 8 of them. These are McGraw-Hill. And the only reason I tell that to you is that if you're going to go out and buy an ACT practice book, get something other than McGraw-Hill.
Okay.
Because that way we'll always have fresh tests that we can do online with you. Now, these practice tests start out pretty easy. The first 20 or 30 questions are very basic. The last 30 tend to get a little harder. So we'll just go through these as quick as we can. And some of them I won't even make comments on if you understand them. About number 1.
All right. If 2x plus 5 equals 17, then x is... I'm going to write out 2x plus 5 equals 17.
Okay.
And then I'm going to subtract 5.
Okay.
And I'm going to get 12.
Okay.
Equals 2x. And then I divide each side by 2, and x equals 6.
Good. About number 2.
Consider 3 statements below to be true. All horses that run fast are brown. Horse A is not brown. Horse B runs fast. Which of the following statements is true? Horse B is not brown. Horse B is brown.
Okay. You may lose the picture for just a second. Okay. You should be fine now.
All brown horses run fast. All brown horses run fast. Horse A runs fast, and both horse A and horse B are brown. Well, I think the answer is H, because that's what they told us.
Well, no, they actually said that all horses that run brown are fast, which is not the same thing as saying that all horses that are brown run fast.
Or all horses that run fast are brown. All brown horses are fast. So then horse B is brown?
Yes. In other words, it's G. If all horses that run fast are brown and horse B is a horse that runs fast, then he has to be brown.
Okay.
This is kind of a problem this is your basic geometry problem when they're talking about proofs. And it's kind of like if P then Q does not mean if Q then P. In other words, if I said if you live in Colorado, then you live in the U.S. Well, you cannot say that if you live in the U.S., you live in Colorado. You don't. There's people who live in Florida that live in the U.S., but they don't live in Colorado. So the most common mistake people make when they see an if P then Q statement is to assume that if Q then P. And notice that that's what H says. In other words, the statement said all horses that run fast are brown, and H says all brown horses run fast. So that's kind of saying if Q then P. It's a subtle point and one that we don't need to spend a whole lot of time on.
Nope, I got it.
Let's go to 3.
How much greater than x minus 2 is x plus 5? 3.
If I said to you, how much greater is 7 than 3? What would you do?
7 is 4 greater than 3.
And you got that by subtracting the 2.
Yeah.
So in this case, it's saying how much greater than this is this. So the x plus 5 is the 7, and the x minus 2 is the 3, so I have to subtract. I have to do, hold on, I have to do x plus 5 minus x minus 2. In other words, that's how much greater x plus 5 is than x minus 2. Well, what's the answer to this? When you distribute this negative sign to both terms in the parentheses, what do we end up with? In other words, the first step here is to lose the parentheses. Well, I can lose the front set of parentheses without affecting anything. But then when I get rid of this set of parentheses, what am I left with?
X plus 2?
Minus x plus 2, exactly. And now if you simplify that, you get 7. So x plus 5 is 7 greater than x minus 2.
Alright, so are we doing 4 now?
Yeah. And you know what? I think it's probably better if you read these to yourself rather than out loud. And the only reason I say that is when you go to take the ACT test, you're going to have 50 other people in the room, and you're not going to read these out loud.
No, yeah.
You read them to yourself. So let's practice them that way. What they're basically asking is, what is A of 15?
And then do I plug in 4 times 15?
Yes. In other words, this notation over here, this is important to learn. If this says you have a function A that is a function of B, meaning the only variable on the other side of the equation is going to be B. And this says, well, wherever you find that variable, plug in 15. What do you get?
Alright, so 4 times 15.
Do you have a calculator in front of you, Emily?
Yes, I do. It's 60.
Go ahead and use it. You're going to be able to use it on the ACT test. So we want to set you up in exactly the mode you're going to be when you take that ACT test. So 60 minus 30 is 30.
30.
Okay. Now, in all honesty, the calculator is not going to help you nearly as much as people think it does, only because they tend to set these tests up so that you don't really need a calculator. In fact, sometimes the calculator can actually drive you in the wrong direction, truly. So know that there might be, out of the 60 questions on this test, there might be 3 where you really can benefit by using a calculator. And that's it. Seriously, that's it. You could do just fine on this test if you did not have a calculator. Tell me how you're going to do number 5.
All right, number 5. All right, so we need to figure out 20% off of 660.
Okay. Go ahead and use your calculator. What is that? What's 20% of $6.60?
It's $1.32. So we take 660 minus $1.32.
Okay. And we get 528.
Yeah.
Now, notice that that was 2 steps. Well, I can do this problem in 1 step. Instead of taking 20% and subtracting it, what if I just take 80%? In other words, if something is 20% off, then it means you're paying 80%. So if I put this into my calculator in 1 step, I get the immediate answer. Don't have to do it in 2 steps.
That's fast.
Plus, it applies when you say that something appreciated by, say, 15%. Let's say that these 12 cans of soda went up by 15%. Well, you don't need to multiply it by 15% and then add it to that. You could just take that and multiply the whole thing by 1.15. In other words, whether you're going up or down, you can always use this logic. And it always saves 1 step. Number 6.
All right, 6.
What's A? What's A equal?
A equals 8.
Most common mistake in algebra is that one right there. A equals plus or minus 8.
Oh, yeah.
Notice that each one satisfies this equation. If A were minus 8, minus 8 squared is indeed equal to 64. And what's B going to be?
Plus minus 9.
Okay, now we have lots of combinations. Can minus 17 be an answer? If I choose, if I choose the minus 8 and the minus 9, I get minus 17. Can minus 1 be an answer?
Yes.
Can plus 1?
Yes.
Can 17?
Yes.
Can 145?
No.
All right.
All right, 7.
Mm-hmm.
All right, so for 7, it's going to be 180 minus 40.
Okay. That's good. Let's just talk a little bit about parallel lines and transversals. Incidentally, notice that this first part of the sentence is immaterial. In fact, it doesn't even make sense because they don't even mark off what AC is. So how can B be the midpoint of AC? And it's not critical to the answer. It has nothing to do with the answer. But let's talk about parallel lines, because when you take geometry, they give you an awful lot of information about parallel lines. You really don't need it all. You only need to remember one thing. When I have two parallel lines and I have a transversal, I create 8 angles. But in reality, I only create 2 unique angles. And that's 1 and 2. In other words, every obtuse angle in this diagram is number 1. Every acute angle is number 2. So 3 is the same as 2, 7 is the same as 2, 6 is the same as 2, 1 is the same as 8, 1 is the same as 5, 1 is the same as 4. And finally, 1 and 2 are supplemental, meaning they always add to 180 degrees. So, when I first look at this picture and this diagram, I know that this angle right here is an acute angle. That means it's got to be 40 degrees. Because 40 degrees is one of the angles that was created when we drew this transversal. Which means this one is 40, that one has to be 140. The other way to look at this is that's acute, that's obtuse. You know they have to be supplemental, so you can immediately come up with 140 for that. But notice that it has nothing to do with whether B is the midpoint of AC, as the first part of their sentence says. And this is very common in the ACT test, in that they will frequently give you information that is not relevant, if for no other reason than in an attempt to confuse you. Like I said, they don't even put endpoints on AC, so it doesn't make sense to say B is the midpoint of AC, unless you want to consider that the left endpoint and that the right endpoint. But it has nothing to do with the answer.
Okay. 8.
I could say that this function is called either y or f of x. I'm going to continue to use f of x because there's something more powerful about f of x than there is when you use y. And that is, I'm allowed to ask questions like this. That's what this question is saying, is if this function is f of x, then what is f of minus 3? What do?
Try it out.
Well, you plug in minus 3 wherever you see x. If that's what you mean by try it out. And yeah. I honestly think that the very first step you should do here is always this one. Do not shorten it. Do not try to do 2 of these steps at once, because all of these negative signs can mess you up. Now simplify that. What's minus 3 squared?
Minus 3 squared is 9.
Okay, what goes next?
6 times negative
now, what does all of that reduce to?
18.
Plus 18.
Yes.
And I need the plus sign. I can't write just 18. The plus sign would not be implied. It just wouldn't mean anything. In other words, if I wrote that, that would mean nothing. But we're adding these or subtracting them, so I have to put the sign in front of it. And then minus 18, what's that whole thing equal to?
18. Okay. It's just 9, because they cancel each other out.
I would suggest to you that problems like this, you try to do without the calculator. In other words, this is not something you should need a calculator for. You should instantly be able to see that the plus 18 cancels with the minus 18, and the only thing you have left is 9.
Yes.
All right. So that means what? What does that symbol mean?
Is it just separating them?
It's absolute value.
Oh, I haven't learned that yet.
Oh, you haven't? Okay. Well, you will when you take algebra. But absolute value just means whatever the number that results in there, take the positive value of it. In other words, if this were minus 17, then the absolute value of it would be 17. It's pretty straightforward, actually. So when a is 12, what do you get? In other words, I could also write this as f of x. That's the function. And now I want to evaluate it at f. Well, I can't really call it f of x because this is a. So I have to say that that's f of a. And now I want to evaluate it when a is 12. So plug in 12 for a. What's 1 minus 12?
1 minus 12 is negative 11.
What's the absolute value of negative 11? Always whatever it is without the sign. So it's 11. Okay, you understand? In other words, the absolute value of 13 is 13. The absolute value of negative 13 is 13. Just whatever the sign is, make it positive. That's basically all you need to know about absolute values. Okay, how about number 10? So I have AB equals C, and I have C equals KB. What statement can I make based on those two equations?
That KB equals AB.
Okay, so AB equals KB. And now what can I do to solve for K?
Solve for K?
K is what they want to know.
I don't know.
Well, how about we divide both sides by B? In other words, the last step in solving any equation is usually to divide by the coefficient of whatever it is you're trying to solve for. So if I'm trying to solve for K, I want to divide by its coefficient, which is B. And if I divide that side by B, I got to divide that side by B, and I'm left with A equals K, or K equals A. Now, there is one time where you can't do this, and that's if B could be 0. But this statement right here that says B times C is not equal to 0 tells you that b can't be 0, because if b were 0, then b times c would be 0. 0 times any number is 0. So this tells you that neither b nor c is 0, and it's okay to do this step. Divide both sides by a number that's not 0. If b could be 0, that might be a dangerous step. If b equals 0 or a solution, you would lose it. But in this case, you can do it. Okay, let's go to the next page. Okay, here we need rules of exponents. What do you do when you have double exponentiation? Which is what I call this. I don't know if that's what mathematicians call it, but...
I haven't done this either.
Okay.
Do you just multiply 3 times 13?
Yes, that's exactly what you do. But as long as we're here, let's go through these rules, because you'll definitely get them, and this is good. It points out what we should cover and what we shouldn't cover. If I have b, let's cover this problem up for a moment, because I don't want to confuse the variables. If I have b to the x times b to the y, I add the exponents. Same base, different exponents. That's the answer. In other words, if I had 3 to the 4th times 3 to the 5th, that would be 3 to the 9th. Okay? That's rule number 1. Rule number 2. If division is happening instead of multiplication, I'm going to subtract the exponents. For example, if I had 3 to the 5th divided by 3 to the 4th, that's equal to 3 to the 1st, or just 3. And one way I memorize these 3 rules, there's one more coming, is that what you do with the exponents is one level less mathematically than what you're doing with the bases. I am multiplying the bases, therefore I'm going to add the exponents. Or I am dividing the bases, therefore I'm going to subtract the exponents. Subtraction is one level less than division. Addition is one level less than multiplication. And the third rule is what I call double exponentiation, which was the problem we were just looking at, where you have the variable or the base being exponentiated and then the whole thing in parentheses is being exponentiated. Well, multiplication is one level less than double exponentiation. That's always going to be that. And that was our problem in this problem, is that we had x to the 3rd, all of it being taken to the 13th power. So I'm going to multiply 3 times 13, and I get x to the 39.
So what do you call this again?
I'm sorry, what?
What do you call this again?
X to the 39?
When you have the parentheses on top of the parentheses.
Yes, correct. In other words, this is the third case down here. And I didn't want to look at this because in this case, x is the base, not the exponent. So I didn't want to confuse you by relating this to this. But this problem, b to the x to the y, is the same as x to the 3rd to the 13th. In other words, the x is the 3 and the y is the 13. So whenever you have this situation, you're going to multiply exponents. And it doesn't matter whether this is an x, a b, a 7. In other words, if I had 7 to the 3rd to the 13th, That's 7 to the 39th. All right.
All right.
It's probably a good stopping point. And next time we can pick up at 12.
Fantastic.
All right, Emily. And next time, you don't need to call me if you don't want. I will text you the meeting ID number at least 1 or 2 minutes before the schedule.
Sounds good.
And I will just text it to this phone number that I have on file. I've got you in my memory now, in my contacts.
Awesome. And I have my new phone, so there's no switching numbers or anything like that.
Let's make sure I have the right one. I just put it in. I've got 720-837-6127.
Yep.
That's what I'll use. All right, Emily. I'll talk to you next time.
All right. Talk to you next time. Thank you.
All right.